Hi, this is Karthik Pandya, and today in this video I will going to demonstrate the learning target 4C for the class 1 CSC 120. So target 4C says that I can define SOP and POS forms both canonical and a standard. So in this video I will going to start from a truth table that you can see in the screen that defines using minterms. I will write the canonical SOP, simplify it to the standard SOP. Then I will gonna write the canonical POS, and finally I will gonna give the simplified standard POS form. I will also clearly define what SOP, POS, canonical and standard mean. So from the function and the truth table you can see there is the function f that gives the output, and this is 4 times true. This is 0 0 1, it's 1. This is 0 1 0, this is 2. 1 0 0 is 4, and 1 1 0 is 6. So from the function we can define the minterms by f equals to ABC is equals to sigma and 1 2 4 and 6. So this means f is equal to 1 for rows 1 2 4 and 6, and f is equal to 0 for the other rows. So SOP stands for sum of a products. That means the expression is an OR of a product's terms. Canonical SOP means we write a minterm for every row where f equals 1, and each minterm includes all variables a, b and c, each after complement or not. So I'm going to write the canonical SOP here. So the 1, we found the 1 for 1 0 0 1, 2 0 0 0 0, 4 and 6. So this is A, B and C. So 0 is A dash, B dash, 1 is C, A dash, B, C dash. 0, it's if it is 0, so then it will be a prime alphabet. If it is 1, so then it will be a normal alphabet. So A, B dash, C dash, A, B and C dash. So for the canonical SOP, we just integrate all of the minterms by A dash, B dash, C plus A dash, B, C dash plus A, B, D, C dash plus A, B and C dash. This is our canonical SOP. And for the standard SOP, we just simplify the whole version. And for here, I'm going to write it as, and I'm taking the C dash out. So in the side, it will be as A dash B, A B dash plus A B. Now simplifying further, I'm taking the A out from here. To B plus B dash. B plus B dash will be 1, and we can see from the Boolean expression A dash plus B, A dash B plus A equals to 1. So A dash B C plus C dash, and this will be as A plus B from the Boolean expression. So this is the correct standard SOP form. So the POS stands for product of sums. That means the expression is an end of a sum terms. Canonical POS means we write a max term for every row where f equals 0, and each max term includes all variables a, b and c. So for the canonical POS, for the truth table, f equals 0 at rows, we can see 0th row, 3rd row, 5th row and 7th row. So for that rows, that equals 0. So now for the canonical POS, rows equals zeros where it's 0 3 5 and 7. So you can write it as f equals to this term 0, 3, 5 and 7 when it is 0. So now I will write each max term. So rule for max terms is if the input bit is 0, use the variable uncomplemented, and if it is 1, use the variable complemented. So for the row 0, it is 0, 0, 0, then it will be A, B and C uncomplemented. Row 3rd, it is 0, 1, 1, so A, B dash, C dash. Row 5, 1, 0, 1, so it is A dash, B, C dash. Row 6, it will be 1, 1, 0, so A dash, B dash, C. And the canonical POS is the multiplication of all the terms. So for the canonical POS, it will be just the multiplication of all the terms, and it has the integration sign between all the plus sign, yeah, and just multiplying all of them in one equation. So A dash B plus C dash and A dash plus B dash plus C. This is the canonical POS. So for the final standard POS, it is a simplified product of some form. A valid simplified standard POS for the same function. Here it will be simplification of all these three. I think I don't have much time left for that, so it will be has the A plus B plus C. Okay, so maybe I made a mistake over here, so it is not row 6, it's row 7. So A dash, B dash, C dash, this is A dash, B dash, C dash. So I'm going to simplify them first. So we know there is an identity, it's x plus y into x plus y dash, so it will be x. So we can look at here, A plus B dash C dash into A plus B C dash. So if we see that if A C dash it's a one term and B dash B is another y term and this 2x term, so you can just directly neglect the B dash and the answer will be A plus C dash. Yeah, so A plus C dash, and we left with A dash, B dash plus C dash. So let's multiply them inside. Okay, so A into A dash 0, A B dash A C dash plus C dash B dash and C dash into C dash. Yeah, or we can just take out the A from here, so B dash plus C dash plus C, taking the C dash from here, so B dash plus C dash, taking the B dash plus C dash out, so A plus C dash into B dash plus C dash. That's the final answer from that term, but we just left with the A plus B plus C also. So F simplified POS will be A plus B plus C into A plus C dash and B dash plus C dash. So I simplified, so I think that's the perfect simplified version of the standard POS. It is simplified compared to the canonical POS. It is still represents the same truth tables. To summarize definitions clearly, so SOP is an OR of n terms, POS is an AND of OR terms, canonical means Every term includes all variables, and standard means the expression is simplified and terms may not include all variables. In this video, I demonstrated target 4C by creating the truth tables, definition, writing canonical SOP, simplifying to standard SOP, writing canonical POS, and giving a simplified standard POS expression that completes my demonstration. Thank you.